Properties of matrix multiplication. Theorem 2.3. We have A, B, C are matrices, and we have a little c is a scalar, represent for a number. Now we have four properties. We have the first one is the associative properties. The second one and the third one, they are both distributive property. And the last one, if you have a C multiply matrix A times B, you can multiply C and A first and then times B, or CB first and then times the A. In the next example, number 3, we will show the associative property of multiplication number 1. So we'll look at the example. We have ABC matrices given, and let's calculate A times B first and then times C. Then the second way, we do BC first and then multiply A. We want to show that the answer or the result in both ways are the same. That means we just prove the first property, associative property. So now we want to multiply this and that, right? The first one and the second one. And we notice that we have 2 by 2 matrix, 2 by 2 matrix for the first one, and we have 2 by 3. Then we have 2 cancel out, so we should get 2 by 3 matrices. Okay, so what do we do is we will multiply this and this. So 1 times 1 plus negative 2 times 3. And then the middle one, we will multiply this and this. So 1 times 0 plus negative 2 times negative 2. The last one for the first column, we will do 1 times 2 and plus negative 2 times 1. Okay, then similarly, we will use the second row and multiply column 1, 2, 3 for the second one. So 2 times 1 plus negative 1 times 3, 2 times 0 plus negative 1 times negative 2, 2 times 2 plus negative 1 times 1. And then we carry the last matrix again. And then we simplify the first one, the first product. So we got 1 plus negative 6, so it should be negative 5, positive 4, got 0 here, and then negative 1, 2, and 3. Then let's copy the negative 1, 0, 3, 1, 2, 4. Okay, so now what do we have is we have 2 by 3 and we have 3 by 2. So our final answer we should get is 2 by 2 matrix. Okay, so we will use this one, multiply this, and then multiply this, right? So 5, negative 5 times negative 1 plus 4 times 3 plus 0 times 2. And then, okay, and then we have negative 5 times 0 plus 4 times 1 plus 0 times 4. In the bottom, we have negative 1 times negative 1 plus 2 times 3 plus 3 times 2. Negative 1 times 0 plus 2 times 1 plus 3 times 4. Now simplify the result. So it's positive 6 plus 12 is this is positive 5 plus 12 is positive 17. The second part we got 4 because this is 0. And then we have 13 and 14. Okay, so similarly you will work on these two first and then copy down the first one. Okay, you will work the same way. So you have this times this and then times that, right? So we work it out. To save the time, I would write out the result. So we get 3, 8, negative 7, 2. From the product of the two last matrices, and then we multiply 1 times 3 plus negative 2 times negative 7, 1 times 8 plus negative 2 times 2, 2 times 3 plus negative 1 times negative 7, 2 times 8 plus negative 1 times 2. Okay, so simplify this. So we have 3 right here, 14 right here, so that will make 17. 8 plus negative 4, so it's positive 4, 13 in the bottom and 14 in the bottom. So we compare the result, and so we see that this and this are the same. So we conclude that A, B, C, so A times B times C equal to leave the A and B times C. Okay, so the next example is AB and BA. We want to show that they are not equal. So the meaning of these matrices most of the time is not equal. We have some special case, but we always should assume that they should be equal. So it's called commutative property. It's not true. Okay, so let's calculate A times B. 1 times 2 plus 3 times 0, 1 times negative 1 plus 3 times 2, 2 times 2 plus negative 1 times 0, 2 times negative 1 plus negative 1 times 2. So the answer that we got is for A times B is 2, 5, 4, and negative 4. Now we work on the B times A. Okay, so 2 times 1 plus negative 1 times 2, 2 times 3 plus negative 1 times negative 1, 0 times 1 plus 2 times 2, 0 times 3 plus 2 times negative 1. And then simplify them, right? So we got 0 right here. 2 times 3 is 6. 6 plus 1 is 7. We have 4 in here, and then we got negative 2. So we conclude that AB is not equal to BA.